Why does learning matter? Why does the knowledge we acquire in one situation hold value in another? The answer lies in the concept of transfer learning, a method that has revolutionized not only our understanding of learning, but also its application in diverse fields, especially in areas where data may be scarce. To trace the history of transfer learning, we must venture back to the late 20th century. In the 1990s, the concept started to take shape, being applied in fields like psychology to understand how humans apply knowledge from one context to another. However, it was not until the advent of the 21st century, with the rise of artificial intelligence, that the true potential of transfer learning began to unfold. Now that we've seen the history of transfer learning, let's look at some tangible examples of how this concept has been applied in machine learning. Firstly, consider the case of Google's Inception model. This model was initially trained on the ImageNet dataset, a vast collection of images categorized into thousands of classes. This pre-trained model was then used to classify flowers with a small dataset, demonstrating how transfer learning can leverage existing knowledge to solve new problems efficiently. Secondly, in the realm of natural language processing, pre-trained word embeddings like Word2Vec and GloVe have been instrumental. These models, trained on massive linguistic datasets, have been used to understand and process text for various tasks, ranging from sentiment analysis to machine translation, thus vastly improving the performance of these tasks. Lastly, in the field of reinforcement learning, transfer learning has been used where the knowledge gained from one game is transferred to another. This has significantly sped up the learning process, allowing AI to master new games at an unprecedented pace. These examples illustrate the power and versatility of transfer learning in machine learning, setting the stage for its role in the even more complex field of deep learning, which we will explore next. The early 2000s saw transfer learning being used in machine learning models, with the goal of improving the accuracy of predictions. The idea was simple yet powerful: to leverage the knowledge gained from one task to enhance the performance in another, related task. This approach was a game changer as it reduced the need for extensive data for each new task. Having understood the basics of transfer learning in machine learning and its further integration into deep learning, let's dive into some practical examples of transfer learning in deep learning. One notable example is the fine-tuning of pre-trained models like VGG16 or ResNet for specific tasks. These models, initially trained on extensive datasets like ImageNet, can be tweaked to perform exceptionally well on specific tasks with smaller datasets. Another example is using these pre-trained models for feature extraction in tasks like object detection and segmentation. This approach allows us to use the knowledge these models have gained about various visual features to enhance the performance of our specific task. Lastly, transfer learning has also found its way into generative adversarial networks or GANs. Here, a model trained on one dataset can be used to generate data for another, thus saving significant computational resources. These instances illustrate the significant improvements in AI systems brought about by the strategic application of transfer learning. In the mid-2000s, transfer learning made a significant leap forward. It was integrated into deep learning, a subset of machine learning, which led to a dramatic improvement in the performance of AI systems. This period marked a turning point in the history of AI as transfer learning became an integral part of the AI toolkit. Let's explore some examples of how transfer learning is revolutionizing the medical field. First, pre-trained models on large-scale image datasets are being used to detect diseases in medical imaging, significantly improving diagnostic accuracy. Second, in genomics, transfer learning is being used to predict gene expression levels, helping to advance personalized medicine. And third, electronic health records are being utilized in a transfer learning context to predict patient outcomes, enabling healthcare professionals to make more informed decisions in patient care. These examples demonstrate the transformative power of transfer learning in healthcare. Now, fast forward to the present day. Transfer learning has found its way into the medical field, opening up new possibilities for healthcare professionals and patients alike. It has proven instrumental in areas such as medical imaging, where it has helped create more accurate diagnostic tools, and personalized medicine, where it has enabled doctors to tailor treatments to individual patients based on their unique health profiles. So what does all of this tell us about transfer learning? First, it underscores the importance of learning, not just for the sake of acquiring knowledge, but also for the ability to apply that knowledge in different contexts. Second, it highlights the transformative power of transfer learning, from its early applications in psychology to its current use in groundbreaking medical technologies. Third, it points to the future of transfer learning, as it continues to evolve and find new applications in diverse fields. In conclusion, transfer learning has come a long way since its inception. It has not only revolutionized the field of AI, but it has also made significant strides in the medical field, improving patient care and outcomes. As we move forward, the potential of transfer learning is boundless, promising to reshape our understanding of learning and its application in myriad ways. With this knowledge, we can tackle new challenges, make new discoveries, and continue to push the boundaries of what is possible.